Welcome to Spring LIB.
Okay, so we have our racemic mixture of substrate 1, and through interconversion involved, I'm just going to put an R here for the rest of the molecule. Using haloalkane dehydrogenase, we know we can get S2. Right. But we also know that haloalkane dehydrogenase pretty much only takes, or not only, but mostly, because it's an SN2 reaction, is taking 1R. Maybe I should say R1. That's how it's written over there. R1 to S2. Right? That's what we have a catalyst for. We don't have a catalyst for taking S1 to R2. But it's not impossible to get some of our, right? We have an equal mixture of R1 and S1. We have 50%. R1, 50%. S1. And so if we're using haloalkane dehydrogenase, we know that the best yield we can get of our S2 is 50%. And if this was the only reaction that was possible, our enantiomeric excess would be, massive. Right, but that's not to say that it isn't impossible for some of our S1 to turn into R2. It's just not going to be a low energy barrier pathway. And so if we can restrict the conversion of R of 1 to 2 and only being R to S, then we can get a high enantiomeric excess, but our yield is limited to 50%, right? Because we can only get a high EE if we're only getting 1 to 2 in terms of R1 into S2. But say if we heat the mixture or some impurities allow some of our S1 to turn into R2, our yield might go up. But that means our enantiomeric excess would go down. In terms of diagrams that you could show this with, I mean, you can't really, there's not really a mechanism that would show this in terms of a diagram. One could look at something like this, here's our R1. And our S1. And the idea is that as they currently are, they cannot really interconvert, right? Some, and that R1 can easily, sorry, I drew this weirdly, can convert into S2. And our S1 can convert into our SR. So what we'd like to happen is that we add enough energy to the system that R1 can get over the hump to become S2, but S1 can't get over the hump to turn into, should be R2. Right. But if we let it go long enough or heat this enough or, push it forward, over time, we will end up getting some S1 that converts to R2 just naturally. And basically, if we, use heat to try to increase our yield of S2, right, pushing this line up to try and get more of our R1 converted to S2, there's no way to avoid also allowing S1 to turn into R2, even if it's to a lesser extent. And if the concentration of R2 goes up, that means our enantiomeric excess goes down. So in order to increase our yield of S2, we have to necessarily increase our yield of R2, which is going to decrease the purity of our product, right? The purity being that we only want S2.